Welcome to question 22. This question 22a, is on vectors under category position vectors. Position vectors are the vectors which rely on the origin being represented by O. For example, this is our x or y. It's a vector which can always start from O, going somewhere. So it is dependent of the origin, which is O. So we call them position vectors. So question A says M is the point 0,5. So if 0,5 is a point, as a vector, we'll write OM is equal to, we'll write as a column vector, column matrix form, in column matrix form. The way it was brought, it is in coordinate form. If you write it like this, it is in column vector form or column matrix form. So now, take note that vector Mn was also given, which was -3, 4, already written as in vector column form. Now they want us to find vector On. So now we use this Mn. Mn, how do you move? You start with the same M, you write Mo. Remember we said the position vector is dependent on O, which is the origin. So Mn always go like Mo plus the same On. You see, this M is this M, this N is this N. So if we were to cancel, as you can see, we have OO, which are the same. If we were to cancel OO, we'll have Mn, which is the question itself. Now let us replace. Mn was given as -3 and 4. Right? Don't write over. Let me rewrite this. Mn was given as -3 and 4. Mo, you see, Mo, we were given OM, not Mo, but they will be the same. You see, it's just that it's the opposite of this. So since it's opposite, as you can see, how it is starting, and this one, you write in negative, but with the same units inside, with the same entries inside, plus ON. Remember, the question is talking about finding ON, which is here. So you make this one cross the other side, so that we have ON remaining. So here we have -3 and 4. Negative will cross to become plus. So you're going to have this. Indeed, ON has remained. So -3 plus 0, this is how you add. What is -3 plus 0? What is 4 plus 5? So -3 plus 0 is -3. 4 plus 5, it is 9. And this is a vector for ON. That's all. So if the question was talking about writing as a coordinate, let's assume they say write the coordinate. So coordinate of N, you use N like this, then you do this, write as a coordinate form, in coordinate form, -3, 9. You see the difference? See the difference? As a vector, it will go like ON with an arrow, and as in a column way, and as a coordinate, you write just N with -3, N in this way. This is what you would have done if it was that way. So vector ON is this answer. We move on. So question B says, the sketch shown below represents the graph of the curve y is equal to x squared minus 4x plus 3 passing through the points A, B, and C. A, B, and C. So as you can see, BC, the way they are, we call them the x-intercepts. because they are crossing. This graph is crossing x-axis on B and C. Therefore, BC are called the x-intercepts. The A, as you can see, the graph is crossing this y-axis at A. Therefore, A will be called the y-intercept. Take note that always the y-intercept is the number, the constant that you have. So in this case, y-intercept is 3. Take note, y-intercept is 3. It means if they were to ask you about the coordinate of A, you'd have written 0,3 as your A coordinate. You would have written like this. So now, find the coordinates of points B and C. B and C, which are the x coordinates. As you can see, the B, if we had the 4 here, it was going to be 4, 0. So a coordinate will possess x value and a y value. Just like for C also, there will be an x value and a y value. So here, the x value is missing, but the y value is 0 because there's a 0 here. Even here, the x value is missing on C, but the y value is 0. So as you can see, x values are missing. Once we find them, we'll be able to put them here. So get this, you have x squared minus 4x plus 3 just equate to 0. Equate to 0. This one now, you call it quadratic equation. The way it was, this is a quadratic function question. Quadratic function question. When finding the x values, you turn it into a quadratic equation like this. So here, you can look for the product. I can use factorization method. So product, sum, factors. Look for the product, sum, factors. Product, you multiply the coefficient that you have here, which is a 1, times the last number, which is the constant. So 1 times 3 is 3. Sum, you get the middle number, the one which is bearing an x, together with the sign, -4. Then look for two numbers. When you multiply, you get 3. When you add, you get -4. So try this. 1, -1, and -3. Try them. So -1 times -3. Do you get +3? Yes. Product. Product means what you get when you multiply. Then add this, -1 plus -3. So positive times negative, it will be negative, so meaning -3. So -1 minus 3, you have -4, which is the sum as given here. So when we multiply these two, we'll get +3, as you can see. When we add, we'll get -4 as given. So these are the true factors that we should use. So what you do, just replace here. Instead of writing -4x, write these factors instead. Write these factors instead. So -1, write -1x, same as writing -x because we are replacing here. The second one is -3, write -3 in terms of x because we are replacing here. As you can see, -1x minus 3x, you still go back to -4x. Then this plus 3, write it the way it is, then is equal to 0. You factorize, since we are using factorization method. You factorize the first two and the last two. The first two, which one is common in these two is x. Then x will remain here, and here there will be 1. Try to multiply if you'll be able to get back what is on top. X times x, x squared. X times x times -1, -x. So what did we do? you can simply do this. For you to get this, you divide x squared over x. Let's say x squared over x. You are aware x squared same as x times x over x. Cancel, x will remain. And here you divide also x over x is 1. And when you multiply, you go back to that. And here, which one is common? A common factor is, now this minus, write it here, just carry it over. But this 3 is common, write it like this. Once you do that, just know that whatever is here, even here, to be the same. Try to multiply if you go back to that. Negative 3 times x, negative 3x. Negative 3 times negative 1, you go back to positive 3. So now, since these are the same, x minus 1 is equal to, you write like that, x minus 1 is common. Also, so when you get x minus 1, you have x remaining here. See, never mind this. You have x remaining here. Negative 3 will remain there. Then you equate to 0. X minus 1 is equal to 0. Or this x minus 3 is also equal to 0. Negative 1 will cross, it will be 0 plus 1. The sign will change. So 0 plus 1, 1. X minus 3, this negative 3 will cross, it will be 0 plus 3. Then x will be 3. So you see, we have gotten the x-intercepts. So now, if you go back here, we said the x values were missing. So, between B and C, which one will be 1? Which one will be 1? And 3, which one will be 1? Between these two, which one will be 1? The other one 3. So it means on B it will be 1, 0. And here on C it will be 3, 0. So same as replacing here, x was 1, meaning 1, 0 as our B. And C is 3, 0. These are the coordinates of B and C. Question 1. Question 2. Question 2, they are talking about finding the minimum value of y. So now, minimum value of y, it is where the line is turning. So we need to get it here. The turning line, the turning point. Now we get the y value. Because if it is looking like holding water, we need to have the minimum value. If it was going to be like this, we're going to get the maximum value from there. So, remember that this one is in the middle. We need to get the x value first so that we're able to find the minimum value here. So here is halfway of BC. So no need of using a formula. Yes, there's a formula, but no need of using a formula because formulae can easily be forgotten. Just get a skill on how to find the symmetry. Meaning halfway of BC. So now what you do, remember this one, we found B to be 1, 0 and C to be 3, 0. So these are the x values, which are the x-intercepts. So you write, we want B, right? So you write x is equal to 1 plus 3 halfway, meaning over 2. So this will be 4 over 2, which is 2. So this x is equal to 2 is also called the symmetry, meaning it is cutting BC into 2 equal parts. Now, since this is a 2, what will be the y value here? So therefore, you get the original function or equation, y is equal to x squared minus 4x plus 3. So where there's x, put 2 to find the y, which is missing. So now, where there's x, we put 2. So 2 squared is 4. 4 times 2 is 8. Then here, plus 3. 4 minus 8, you get negative 4. Negative 4 plus 3, you get negative 1. So here, it means the minimum value here is negative 1. So this answer, y is equal to is negative 1. Y is equal to negative 1 is our minimum value. See that? Is our minimum value. This is what you do. Now, what if they ask you to say, find the coordinates of the turning point? The coordinates of the turning point, where it is turning, remember here we have gotten this to be 2, comma, negative 1. So turning point, you get this 2, that was here, the symmetry, and the minimum value. So you say turning point will be 2, comma, negative 1. As you can see, this 2 is for x value and the negative 1 is for y value. So turning point was going to be this one. Equation of the symmetry, if they were to ask, was going to be this one. So please make sure you go through for you to remember these simple concepts.